Okay, but this year we're going to do it a bit different. I'm going to let you do the food test one round. Then after that, I'll let you play with chemicals and modify the experiment any way you want. Alright? Then you see what happens from there. Okay, so today we're going to do the vocabulary of nucleic acids. So far, this is our journey. We started off with talking about how atoms bond or interact with each other. Yeah? There are many kinds of interactions we've come across so far. We've come across covalent bonds. Then we realized that covalent bonds come in the form of polar and non-polar. We also came across hydrogen bonding. We also came across hydrophobic interactions. Then from there, we finally went into our first biomolecule. Once we know how things bond with each other, then it gives us structure. We first went into lipids. Under lipids, we came across several kinds of lipids. There was the triglyceride, and then there was the steroid, and then there's this very special lipid called phospholipid. Okay. This lipid is special because it has both hydrophobic as well as hydrophilic properties, which makes it amphipathic. Okay, simple A. Okay, I'll do a quick summary. Then after that, we went into carbohydrates. Under carbohydrates, we came across several kinds of carbohydrates, beginning first with monosaccharides, then disaccharides, and then finally polysaccharides. Under monosaccharides, what's most important for you to know is glucose. And we know that glucose comes in two forms, alpha and beta. From there, we also know that glucose can form several kinds of polysaccharides, such as starch, which comes in two forms, amylopectin as well as amylose. We also know that there is glycogen, which is animal form of starch, and then finally we know that there's cellulose, which is what is found in our paper that you were carrying that day, cellulose. The skill here is for you to compare and contrast these things. Today, we're going to go into the next biomolecule, nucleic acids. And you've actually come across this particular biomolecule before. It's in your nucleus. You've heard of DNA? Yeah? Okay, so DNA, that's what we're going to dive into for these few lessons. DNA. If I were to expand out what DNA stands for, it stands for deoxyribonucleic acid. Okay, so we're going to spend time in this particular chapter. I would also like to challenge everyone here. On Google Classroom, I just sent a virtual model of the DNA. If you like to, you can pull it out now to have a look. This is what a virtual model of DNA looks like. It's extremely complicated, but very elegantly beautiful. Yeah, I have a challenge that I put across to all my classes every year. You can team up in pairs. Remember that day we built carbohydrates, we built glucose, right? Okay. So you can team up in pairs. And then I'll provide you all the molecules, atoms needed. And if you can build it in the fastest time this year, you'll get a free meal from me. Okay? So several have signed up for the competition. If you want to, you can also sign up. Let me know if you're interested. Sign up in pairs. This is what I will provide to you every atom possible. Okay? The competition goes like that. You will find a partner, you sit down, you have all the pieces in front of you, then you put your phone in front of you, time lapse. Then you will record your time. Fastest time will go out on the scoreboard. I'm going to find out what's your senior's timing. Your seniors managed to do it pretty fast. Okay? So if you have this model pulled out on your iPad, you can play with the model for now. When you look at to the right hand side, you'll see several buttons you can press. You can press backbone, you can press cartoon, you can press space fill, you can press ball and stick, which is what we started off with. You can also color all the groups by group, or by chain, or by pairs, elements. Okay, you can also show hydrogen bonding. You can also, okay, at the bottom right hand corner, you see click here. When you click here, all the hydrogens will also appear. Okay, hydrogens are the white atoms. Okay, so you can keep this model to your side. Right, today we're going to start off with an activity. Okay, I'd like you to pull out your class activity. We're going to look at the very first page of your class activity. To understand this chapter well, you must have a good grasp of the vocabulary in this chapter. Okay? You must have a good grasp of the vocabulary here. If you have a good grasp of the vocabulary, you will spend the first few minutes of lessons trying to make sense of it. Okay? I would like all of you now to look to your left, to your right, find a partner, or you can work in groups of 3. We're going to begin this activity very soon. Okay, what we're going to do for this particular activity, using whatever means possible, you can search through your textbook, you can go through online research. I would like us as a class to find out how all these terms are related to each other. Okay. Do you see these words? Okay, I'm going to direct you. There are 3 rows of words. The first row is over here, nucleoside, nucleotide, purine, pyrimidine. This is the second row of words. This is one word together. Nucleoside phosphate, nucleoside monophosphate, so on and so forth. This is the last row of words. Your task now is to create a relationship map of how all these words relate to each other. You may draw, okay, up to you how you want to do it. You may draw diagrams, you may copy and paste images from the internet, you may also draw a mind map. But our task at the end of 15 minutes is to make sense of how all these words relate with each other. And then I will run through with you and see what we've got. Okay? We must have a good grasp of the vocabulary before we can understand this chapter well. Alright? So perhaps just to give you some idea of what these words mean, here we have a molecule of DNA. Okay, this DNA. Actually, you've seen this structure before in maybe a simplified form. See before, right? DNA often comes in like, they often draw it like that, and then they draw lines in between, right? Okay, so we try to make sense of this structure. But for today, all these words, right, help you understand just one part. Okay? You notice that when we look at this DNA molecule, there are repeating units. They repeat themselves along the way. Just like how if we look at polysaccharides, the monomer, which is the repeating unit, is sugar. In this case, we know glucose. For proteins, the monomer is amino acids, the repeating unit. Today, we're going to figure out how all these terms relate to the monomer of DNA. Okay, DNA also has a repeating unit. But what is the repeating unit? Okay, all these words help us understand that. Okay, so right now, we're going to flag off. We're going to have around 15 minutes of time. Oops, no, 15 minutes. Okay, in 15 minutes, work in your pairs or in your triplets to find out the relationship. You may do any of the 3 to find out the relationship, and then we'll share with each other after 15 minutes. Okay, everyone stand by. You ready? Okay, you found your partner? You found someone to work with? Okay, ready? Okay, your time starts now. What is up? We'll run through now. Right. Okay, let's look through the vocab. Yeah, getting start by right now. Kamin, oh yeah, Kamin is not by right. Are you also the science rep? Like for everything? Okay. Is it very tough to be all three? Okay, good. Alright, I don't know if many of you did this, but actually if you Google, you'll be able to find, yeah? Okay. Nucleotide versus nucleoside. Okay, oh, it's my parts. Okay, then you go to images. Actually, you will see a jackpot image. Anyone found this image? Anyone? Raise your hand. Okay, for those that found the image, you realize you have actually found the jackpot. Okay? If you'd like to, you can go and type this online, nucleotide versus nucleoside. Okay? You can Google this image. After you find this image, you can go and copy and paste inside your book also. Better image. Okay, if you go to Wikidog has a pretty good image. Okay, you go and type nucleotide Wikidog, then you should see something like that. It's quite a good summary of how all the terms relate to each other. Okay, then we're going to try and make sense of the terms now. See if we align with each other before we move on. Okay, first and foremost, in your research, what do we call this central thing that all others blind to? There's this 5-carbon structure in the middle. Glucose? Okay, it's not glucose, but close up. Okay, somebody say ribose. Notice it comes with an OSE behind, like glucose, sucrose, fructose. So it is a sugar. Okay? That ring structure you see in the middle, it is actually a sugar. Okay, so just take note, this middle thing is a sugar. More specifically, you can see 2 kinds of sugar. You just copy and paste what are you doing? What are you doing? Just like take from the internet.
Yeah, but
too lazy. Okay, so this is a sugar. How you know it's a sugar? Because of the name itself. Okay? I hope many of you observe that depending on what's bonded to carbon 2, whether it's an OH or H, the name of the sugar can change. Okay, so I'd like you to pay attention to the whiteboard. Just like glucose, you can number off the carbons. Okay, so you number off this way. To the right hand side is carbon number 1. Okay, so there's a carbon over here. This is carbon number 2, carbon number 3, carbon number 4, carbon number 5 is up here. Okay, you can number off your carbons. Carbon number 2 is a special carbon because at carbon number 2, it can either be bonded to OH or H. Depending on which one is bonded to carbon number 2, the name is different. So if it's bonded to OH, we call it a ribose sugar. If it's bonded to H, we call it a deoxyribose sugar. Okay, so that's the only difference in terminology. Okay, is that what you found? Okay, so next, today we're going to focus on this. What is the repeating unit of DNA or RNA? Or in other words, what is the monomer? What is the thing that repeats itself within the DNA? Okay, so we're going to build that single unit first. Now let's look to the top right hand corner. You see that it is attached to something called a base. Right? They will often extend out and then they'll put base. Okay? So every monomer of DNA or RNA is made up, number one, of a sugar. And this sugar can either be ribose or deoxyribose, depending on what's and number two. And number two is it also binds to a base and carbon number one. There are 5 different bases that I need you to know. The first classification of bases, we call them purines. Second, we call them pyrimidines. There are 2 purines. If you look at purines versus pyrimidine, the biggest difference is that purine has 2 rings. You see that? Purine has 2 rings. Good news, I don't need you to know the structure. Okay? All I need you to know is the name. So you need to know that under purine, I have adenine as well as guanine. Under pyrimidine, I need you to know that there is cytosine, uracil, as well as thymine. Okay, I don't need you to know the structure. I need to know the names. Okay? This will be very familiar to you the more you use it. Okay? So today's lesson is about the vocabulary of this chapter. You'll see this very, very often. I don't know if you've seen this before, but sometimes DNA, rather than write out the entire name, you may just focus on the first alphabet of these bases. So sometimes you may just see an A, or a G, or a C, or U, or T. Okay? If you are lazy, you can just write the first alphabet. That means to say, at carbon number 1, sometimes you see at the base, they'll write an alphabet instead. They may just write A, or T, or G, or C, or U. They may just write the alphabet. I'll give you an example. Here actually I also have a, here I have the sugar. You see the sugar over here. And then after that, the base is over here. Okay? So sometimes we just write the base as an alphabet. We don't write out the entire structure. It's too much to write. Let me use this example. Okay, so there are many different kinds of bases. So C, G. Okay, the third thing that is bonded to are phosphate groups. You see all the P's? Okay, then notice they segregate. There are 3 levels of P's you can add. You can add 1 phosphate group. Okay, I'm lazy, we can just write P in a circle. I could add 2 phosphate groups. I could add 3 phosphate groups. Depending on how many phosphate groups I add, the terminology will be different. If it's 1 phosphate group, you'll find that we will include the word mono in front. If it's 2 phosphate group, we'll add the word di in front. 3 phosphate group, we'll add the word tri in front. Okay. Now, last layer. What is the difference between a nucleoside and a nucleotide? This is the most important thing to get away from today. Okay? Based on what we see, based on what is over here, what's the difference between nucleoside and nucleotide? Okay, you want to ask with your friend first before I call someone to share the answer? Okay, what's the difference between nucleoside and a nucleotide? Okay, ready? Have time to discuss? Nucleoside versus nucleotide. Okay, ready? Okay, Zhishuan, what's the difference between nucleoside and nucleotide? Has a phosphate group. How many? 1 or 2? Close? G1. Okay, nucleotide is 1. Okay, so thank you, Zhishuan. Nucleoside Okay, I'm going to box up what a nucleoside is. A nucleoside is just this. It is just number 1 plus number 2. Correct, Oxygen? Number 1 plus number 2 is what a nucleoside is. Okay, number 1, number 2 is a nucleoside. If we add number 1 plus number 2 plus 1 phosphate, we get a nucleotide. Okay? Or it can be called a nucleoside monophosphate. Okay, so 2 different names. If I add 1 more phosphate, so now it's 2 phosphates now. I will call it a nucleoside diphosphate. Yeah? And if I add 1 more P, then it will be the nucleoside triphosphate. Okay, you can see the difference in the terminology now. Okay, we need to be very familiar with the vocab, then we can make sense of this entire chapter. I think there's 1 more vocab. Something inside the table, they put nucleoside phosphate. Right? You see this? Nucleoside phosphate. Nucleoside phosphate is just a general term. It encompasses the mono, it could be mono, it could be di, it could be tri. It just means that there are phosphate groups. Okay, this is the most general term. This is a general term. But if you want to be very specific, you can be very specific in telling the audience how many phosphate groups there are. Okay? So I'll give you some time to make sense of the vocab. You need to be very familiar with it so that when I start talking about it, you won't feel so lost. Okay, then we can follow along together. Okay, once everyone is done with their notes, I'm going to give a quick summary of what's on the whiteboard. Okay, any questions? So this morning I looked at you on this is the last time I see you. Then you said no, then I was very confused. Okay, ready? Can I go do a quick summary here? Alright, this is the chapter on nucleic acids. The most famous nucleic acid you know is DNA. Today we're just going to look at what's the basic unit, repeating unit of this molecule. The basic unit of this molecule is made of 3 things. The first thing is the sugar in the middle. This sugar can either have an OH and carbon 2. If it's an OH, it will be called ribose sugar. Or it can have an H. If it has H and carbon 2, it will be called a deoxyribose sugar. At carbon 1, it can be bonded to 5 different bases. A or G, which are purines, or CUT, which are pyrimidines. The third thing it needs to be bonded to is a phosphate group. This phosphate group, once added on, we refer to it as a nucleotide. This is the repeating unit of DNA. Everything else is extra. If I would add 1 more, it would be called a nucleoside diphosphate. 1 more, it would be a nucleoside triphosphate. If you forget everything here today, I just want you to know what this is. Go and start this up. You just need to know what a nucleotide is. What is a nucleotide? Let me do it in red. A nucleotide is just this thing over here. Okay? This is the most important thing. Okay, it's the one that repeats itself over and over again in the DNA. Yeah, so if you forget everything, don't understand everything, this is the most important. Just so you know what nucleotide is. 1 plus 2 plus 3 over here. Okay, nucleotide. I'm going to give you some cheats on how to remember whether CUT is pyrimidine, AG is purine. Okay, here's a cheat. My student taught me this. She said right that pyramids are sharp, like pointy, so they can cut you. That's what she told me. Then I remember it forever. Yeah? So this is my hack. Pyramids are sharp, so they can cut you. Then AG will be the other one, purines. Okay? Okay, so that's all for the first part, the vocabulary of nucleic acids. Take some time to touch up your notes. You can talk to each other. If any questions pop up, please let me know before we move on. Yes, Shami? Oh, it's not called base 2. I'm just saying that this is the second thing that needs to bond to the sugar. A nucleotide is made up of 3 things. First one is the sugar, second is the base, third is the phosphate. Yeah, so the number is not part of the naming. I was just numbering off the various parts. So it's not called base 2, just base. Yeah, I was just numbering off the various parts. You have sugar, you have phosphate, you have a base. Okay?
Sugar, phosphate, and base.
Yeah. Okay, in the remaining time, after this, what lesson? Math. Okay, just a very quick activity. I would like you all to work in groups of 3 or 4. Okay, work in groups of 3 or 4. Everyone take one plastic bag. Pass down. Okay, work in groups of 3 or 4. Okay, maybe you all work one more like that. Sorry. Okay. Right. Anyone else? Okay, come on, one more pack. Anyone else? Anyone else? Okay, one more pack. Okay, maybe I give you one more pack here also. Okay. Go ahead. Okay, go ahead. Alright, okay, so inside your pack, you'll find several things. You'll find this large transparency. I don't need that for today. Can you take out the small ones, call out the small ones instead? Put the big one back inside. Okay, put the big one back inside, take out the small ones. What are these small things? Have a look. Can you tell me what these small things are? Hello, O3, what are these small things?
Nucleotide.
Very good. Okay, these are nucleotides. Can you take out all the nucleotides now? Take out all the nucleotides, put it on the table. Okay, ready for our next activity. You know how previously, right, when I gave you 2 glucose, you can condense them together? Okay, now your challenge is this. In your groups, with all the nucleotides are provided to you, and you look at whatever functional groups are present, is there a way you can perform condensation reaction to combine the nucleotides together? Okay, I say again, your task now is to perform condensation reaction to combine the nucleotides together. You can overlap the nucleotides if you want to, alright? But I'd like you to try it out. Previously, we looked at 2-glucose, we find OH groups, right? So in this particular scenario, what will you look out for to perform a condensation reaction? Okay, in the next around 5 minutes, I'd like you in your group to try it out now. Okay, just for fun. Right, then we'll show you how they really combine. Let's see if anyone hits the real way of combining. So this is the nucleotide. Yes.
Is it nucleoside or nucleotide? Nucleoside only means one. Correct.
No, so we only use nucleotides to make DNA or RNA. The only reason why we teach you nucleoside is because in other chapters you will see that sometimes nucleoside but only for DNA, right, we're only using nucleoside. We only use the version of the nucleoside that comes with 1 phosphate.
Only one.
But other chapters you will see that some things we may need 2 phosphate, some need 3. You understand what I'm saying? So how do you think, where do you think you can combine the nucleotides together to form condensation? Okay, then you try it, you overlap. If you think that this way they will combine, right, then you overlap. Okay, so maybe this one more equal. Okay. So how else will you connect everything together? The task for you is to find a way to connect everything together in a repeating pattern. Okay, is there a way to connect all the nucleotides together in a repeating pattern? Just like how you did for glucose. Okay, that is a challenge here. Once you are done, as a group, snap a photo. Okay? Okay, so let's show. How else will you want to get such Has anyone found a way to combine them together in a repeating pattern?
Like this, because one is diagram, the whole thing is there. How do you connect all of them? You see, get it? Because then the O, then the H will be done, right? Right? Then one is right? Yeah.
Oh, I think you all have got everything there. You all managed to repeat already. Okay, you know you've got it if you can combine everything together.
Oh, just correct. But then this one should be.
Can you combine all of them together?
We don't have that one. I don't think we need a dog.
So this combination.
Oh, then but then I want to we do have to accept right now.
You're going around the circle. Oh. As long as you combine everything together, you may have got something really nice. Okay, once you've done your pattern, I would like your groups, everybody take one photo. Okay, everybody take one photo. Once you're done taking the photo, you can refer to your notes and see how DNA actually combines with each other. Okay, take a photo of yours first so that you can compare. Okay, I say again, take a photo of yours so that you can compare. Okay, once you're going to take a photo, go to page 2 of your notes to see how nucleotides condense with each other. See if you got the configuration. If you look at page 2 of the notes, you should see how the nucleotides really combine with each other. Thank you. As I look around, you are inserting your photos into the class activity. Yeah, so that's where you insert your photo. Okay, but this is how the nucleotides will combine with each other. Page 2. Do you combine it this way? Okay, page 2 is how nucleotides will combine with each other. Did your group come up with this method? Because this is actually how they combine with each other. After you see page 2, if you want, you can play around with what's provided and rearrange so that you can see for yourself how they combine. Okay, may I draw your attention to the whiteboard? Okay, so actually where do you join them together? You join them together at carbon number 3 and carbon number 5. Okay, between carbon number 3 and carbon number 5, that's where we will join repeatedly to each other. If you want to, you can hold up one nucleotide, look for carbon number 3 and carbon number 5, because that's where we will repeatedly join them to each other. Okay, so I say again, we will join them, carbon number 3, and also at carbon number 5, one of the phosphate groups come with an OH. Okay, that's where we will combine them with each other, repeatedly in a pattern, okay, to form a straight, nice long chain. Okay, alright, may I get everyone to pack up the nucleotides back into the plastic? We will continue this in our next lesson, I think next week, because tomorrow we'll be going to the lab. Okay, the aim for tomorrow is that you don't blow up my lab. That's all I ask for. Okay, but I allow you for the first time to modify the experiment to your liking. You want to add one more drop to see what happens, go ahead. You always say add 2 drops, then now you want to add one more drop, then you go ahead, see what happens. If you feel like, hey, why must I do the steps in this order? I want to do it in reverse order, go ahead. Okay, up to you what I want to do. Just so as anything is good. may I get you to pass the plastic back to the front? In the remaining time, I'd like you to look at page 2 of your notes, right? And have a look at how the nucleotides combine with each other. Okay, have a look at page 2 of your notes. Yeah, okay, so that's all for today. I'd like you to just spend some time touching up your notes for the rest of the lesson, which is the